Hello students and welcome to the lecture. So students, as we know that the monsoons and the climate in India is a topic that we had started in the previous lecture. And basically in the previous lecture, we had discussed the part 1 of that particular thing. And now we are going to talk about the part 2 of this particular lecture of the monsoons and the climate in India. Alright. So basically in part 1, we have seen about the mechanism of this, the positive and the negative impact of monsoon and all. Now, in this lecture, under the heading of monsoons and the climate in India, we are going to talk about these indexes like the monsoon prediction in India, okay, like the challenges in monsoon forecasting in India. In this, we will discuss the insufficient data collection, quality of weather stations, data gaps, applicability of forecast models, and the human resource constraint in forecasting the monsoon. In the third heading, we are going to talk about the recent initiatives in India. In this, we will discuss the monsoon mission of India, the objectives of those initiatives, the agro-meteorological advisories, the flood management support, the Indo-US expedition, and the national supercomputing mission. Okay. In fourth, we are going to talk about the global warming and the monsoon. In this, we will discuss about the path forward, and then and fifth, we are going to talk about the intertropical convergence zone, but in a proper sense. Like in the previous lecture, we had taken it in the factors that influence the monsoon. We didn't talk about much regarding this. In this lecture, basically, we are going to talk about this in a particular way. The characteristics of the ITCZ, we will look upon this, like the location and the movement, the convergence of trade winds, the weather and the climate effects, the impact on weather patterns. Thereafter, we will see the origin and the name of El Nino. Okay. Then we will talk about the mechanism of El Nino, like the oceanic changes that occurs and the atmospheric changes that occurs during the presence of El Nino. Thereafter, we will talk about the impacts of the El Nino. What does their impacts like on the global weather patterns, on the impact on marine life, then economic and the social impacts also. In 10th heading, we are talk about the phases of El Nino. In what phases the El Nino occurs. And then in the fourth, we will talk about the prediction and monitoring of the monsoon and climate in reference to the El Nino that we have. Okay. So these all are the topics that we are going to look one by one. But before this, here is an disclaimer that we are going to talk about. So in the disclaimer, we can say the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and the owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. Alright. Now, let's come to the monsoon prediction in India. Okay. So this is going to be the topic that we are going to see over here. So if we talk about it, we can say predicting the monsoon in India has evolved significantly over the past century. It means the monsoon is a climate of India, like the Indian climate is a monsoon time climate. But over the past centuries, when we were developing the new technologies and the new satellites that we were launching into the space, over that period of time, basically we have evolved in technology through which we could predict the monsoon pattern. Because we know the monsoon is a season in India. All right. So predicting this season is very, very important for us. All right. Initially, forecast by the Indian Meteorological Department, in short, famously known as IMD, relied on the simple indicators like the snow cover and all. Okay. A century ago, there was a British physicist whose name was Gilbert Walker, who led the IMD, developed a statistical weather model, and this model used the relationship between the specific weather phenomena for the further predictions. All right. So we can say with the establishment of Indian Meteorological Department, we started forecasting the seasonal intensity of the monsoon so that we could plan our things in a proper way even before the arrival of the monsoon. But when we started this prediction, actually the department that we have created for this, that was the Indian Meteorological Department, that was simply relied on the indicators like the snow cover and all. But Gilbert Walker, who was the British physicist, he led the IMD to develop an statistical weather model. This model used relationship between some specific weather phenomena, and on the basis of the data collection, we could make the predictions. Okay. So that was the time period of 2014 when the IMD began integrating the numerical models from the US national centers that were using for environmental predictions alongside some statistical methods for long range forecast. Okay. Despite use of advanced numerical models, forecasting the accuracy that remains a challenge for longer periods due to their increased uncertainty. It means that with the passage of time, we even borrowed the technology from the US national centers that were used to predict the environmental issues and all. Okay. We even equipped the more advanced technologies in our system so that we could predict the environment or the monsoon effectively. But still, after doing all these things, the one thing that still remains a challenge for us is the accuracy. Accuracy prediction is become one of the major challenges in front of us because we couldn't predict the monsoon pattern in an accurate way because the monsoon winds are seasonal and the phenomenal and they could be changed instantly. All right. If we talk about currently the IMD gathers the comprehensive weather data using a network of 679 automatic weather stations, 550 surface observatories, 43 radio stone units. These were the weather balloons, 24 radars and the 3 satellites. It means these equipment still are using in our system so that we could collected the comprehensive weather data. On the basis of this, we could predict the monsoon in India. This data collection is crucial as it's highly advanced dynamical models which requires the supercomputers depend on accurate current weather data so that we could make our effective predictions. All right. Thereafter, we can say the IMD provides district-wise weather forecast. Okay. Although the precisions that they use still varies. For instance, we could say when IMD forecasts the scattered rainfall in some district, it indicates that 26 to 50% of the district area can expect the rainfall. Despite these advancements, the forecasting remains an area where continuous improvement is needed so that we could enhance our prediction accuracy and reliability. It means that even if we are collecting some data regarding some place, still we could not rely on data while predicting the things. We requires more data in the more advanced way so that we could do such kind of things. Got it? So after finishing the monsoon prediction in India, now we are going to talk about the challenges in the monsoon forecasting in India. First challenge that we have is an insufficient data collection. Under the head of insufficient data collection, the first is inadequate monitoring stations. Basically, India lacks a sufficient number of weather monitoring stations. However, we have like 550 and all, but still we do not have the sufficient numbers. Particularly in remote and rural areas, the numbers are even downgrade than the normals. The scarcity results in large geographic areas where weather data is not collected, creates a gap in the data that is necessary for accurate weather forecasting. Thereafter, impact and forecast. Without having an comprehensive data, basically the meteorologists cannot fully understand the local weather patterns. That hinders their ability to predict the monsoon onset, intensity, and the distribution accurately. This lack of precise information can lead to the inaccurate forecast, affecting the agriculture planning and disasters preparedness. After this, the quality of weather stations, the second challenge. So the first is the substandard equipments. Many automatic weather stations that were formerly known as the AWS in India are of low quality, which means these stations often suffer from some technical issues, including the sensors that are poor in nature and outdated technology, which degrade their performance and the reliability in terms of predicting the monsoon or forecasting the monsoon. Here you can say these are the weather stations, and here you can say this is the automatic weather station. These all that are reflecting here. Okay. After this, maintenance needs. Regular calibration and the maintenance are essential to ensure the accuracy of the weather data. However, many AWS lacks the proper maintenance, okay, leading to erroneous data that can skew the forecast improper. For instance, we can say an uncalibrated rainfall gauge may either underreport or overreport the precipitation level. It means that if we talk about this and if we are not doing the maintenance, then what will happen? Our equipments will be working less. Either we will get some underreport or we'll get some overreport, but we won't give some accurate report. All right. Thereafter, the data gaps. So the key factors, if we talk about this, essential meteorological parameters such as dust levels, aerosols, soil moisture, maritime conditions. These are not consistently monitored in India, but these factors play a significant role in influencing the weather patterns and then the monsoon dynamics. After this comes the comprehensive understanding. The absence of data on these critical elements limits the ability of meteorologists to develop a holistic understanding of the monsoon system. For example, the aerosols could affect the cloud formation and the rainfall patterns, and the soil moisture levels influence the hydrological cycles, and the weather predictions. All right. Thereafter, the applicability of the forecast models. First is the imported models. If we talk about this, okay. So we could say in this, many of the forecast models that we use in India are basically adopted from some Western countries. Okay. And that's why these models are generally tailored to the climatic conditions and the existing weather patterns of their regions of origin. Like we could say, the climatic conditions and the weather patterns of Western countries are different from that we have in India. Because the Indian climate is generally a monsoon type of climate. And India is the region which is well known for all the weather types that exist in the world. Alright? But the Western countries we're talking about, these countries generally not having that much of diverse weather conditions. Because of this, whatsoever their forecasting models are, these are moreover tailored to some specific weather condition needs. And because we are adopting the same from them, that's why we also not getting the equipments that could handle the weather patterns and the climatic conditions which are diverse in nature and which are existing in India. Okay. After this, the customization needs. Indian weather patterns are complex and influenced by unique geographical features like the Himalayas, Thar Desert, and the vast Indian Ocean. That limited efforts have been made to customize these models to account for these regional specifications, resulting in a less accurate forecast for India. It means that these complex and the unique influencing geographical features that we have, these are basically the main thing that is posing a challenge in monsoon forecasting. Because the systems that we are using in India for weather forecasting and all, these all are not that much of tailored according to the needs. Then human resource constraint. First is the shortage of skilled professionals. Okay. So if we talk about this, then we can say the Indian Meteorological Department facing a shortage of trained software professionals and meteorological scientists. Okay. And this deficiency basically limiting the department's capacity to develop, to implement, and to refine the advanced forecasting techniques and the models that we require. Okay. Expertise in forecasting. The skilled professional or the personnel basically are generally crucial for analyzing the complex data that presented by the forecasting equipments, also improving the existing models by innovations and all, and making a way to integrate the new technologies into the existing forecasting systems without making much change. This lack of expertise hampers the development of more precise and region-specific weather prediction tools. And because of this, we having the challenges. After finishing the challenges, now what we are going to see or witness is the recent initiatives in India that we have taken to improve these challenges and overcome these challenges. Okay. So basically we can say the first that we have is accurate monsoon predictions. So the accurate monsoon prediction are crucial for farmers' agriculture activities. Like as we had discussed in the previous lecture, mostly farmers in India are totally dependent on monsoon for their irrigation. Why? Because one fraction of the land only or two or third fraction of the land could be irrigated effectively by the artificial means. But the large portion of agriculture fields is totally depend upon the monsoonal rains for their irrigation purposes. All right. And still about 46 or 64% of the Indian population dependent on the agriculture and its related products for their livelihood. Okay. So that's why the monsoon predictions in the accuracy are important. Why? Because on the basis of the collected data, we could formulate a policy for compensation and the support prices. Compensation means if somehow the monsoon rain is that much of high that destroys the crops, then we could compensate the loss of the farmers. And when we previously know that this will be the monsoon rain and this, then automatically we could make actions, we could make changes accordingly. Support price, if the monsoon rains led to the bumper production of crops and all, then the support prices could be used to overcome the large amount of quantity by giving the support price, and the food could be stored with the government institutions that could be used during some adverse situations in future. There are the several initiatives that have been undertaken to enhance forecasting capabilities and provide the timely advisories. The first is Monsoon Mission of India. So basically that was launched by the Ministry of Earth Sciences in 2012. The Monsoon Mission employs the advanced approaches like the high resolution modeling and the data assimilation. These efforts aim to significantly enhance the forecasting accuracy of some Indian meteorological departments and its associates. The initiative has enabled the IMD to utilize the dynamic models for operational seasons forecast that starting with the 2017 monsoon season. So from 2012 to 2017, the time period had been granted to them for improving their technologies. Objectives were improve the seasonal and the intra-seasonal monsoon forecast. It means that from June to September and from October to March, that will be a seasonal forecast. Between June to September, how much will be the rainfall? Between October to March or November, how much will be the rainfall? That will be an intra-seasonal monsoon forecast. Enhance the medium range forecast also. Thereafter, agro-meteorological advisories. The IMD collaborates with the Indian Council of Agriculture Research, ICAR, to provide the district level agro-meteorological advisories in a vernacular language or the local languages that the farmers are comfortable with. These advisories are designed to assist the farmers in some critical agriculture operations like the sowing management of seeds, the variety of crops they could select to grow during that period. Thereafter, the pesticides spray that they could use and how they are going to manage the irrigation management. All these were based on the weather forecast. After this, the flood management support. IMD provides some meteorological support to the Central Water Commission or the CWC for issuing the flood warnings that could be crucial for mitigating the flood impact across the India. All right. After this, the Indo-US expeditions. In 2018, the Indian Ocean research vessel Sagar Nidhi, that you can see in this picture, that embarked on an Indo-US expedition that was aimed at collecting data in the Bay of Bengal. This collaboration seeks to improve prediction models related to the southwest monsoon that heavily influences the India's climate. Then, National Supercomputing Mission. This mission focuses on enhancing the India's computing capabilities to support the advanced meteorological modeling by bridging gaps in supercomputing powers. The mission aims to achieve more accurate and timely monsoon forecast. Then, second point is, these initiatives reflect India's commitment to leveraging the scientific advancement and international collaborations to enhance the monsoon forecasting accuracy, benefiting the agriculture, the water management, disaster preparedness on nationwide level. After this, now we have the global warming and the monsoon. So the climate change has potentially altered the intensity, the duration, the frequency, and the spatial distribution of the monsoon rainfall. However, the definitive conclusions are premature. If these changes are indeed linked to the global warming, they could become the permanent and the potentially accelerate. Conversely, if unrelated to the global warming, the monsoon system might revert to their previous patterns. Further data and reanalysis are essential to distinguish between the impacts of global warming and natural climate variability, such as El Nino events, and to gain a comprehensive understanding of these dynamics. Path forward, if we talk about, as India's population continues to grow, ensuring food security remains paramount. Therefore, it is crucial to harness a significant portion of the monsoon water, currently which is underutilized for irrigation and power generation at some strategic locations. Investing more resources in advancing the prediction of monsoon forecast is imperative, enhancing the reliability and the sustainability. Like adapting to a warming climate where the increased atmospheric moisture may lead to the heavier rainfall, hiding the interannual variability of the monsoon in the future, and this could be checked. Like securing the India's sustainable climate patterns, proactive and timely actions are essential. That's why we had launched a national action plan on climate change and also proactively get engaged at the international level in the UN Framework Convention on the Climate Change, like UNCCC. Thereafter, if we talk about the characteristics of the ITCZ, we can say it is generally close to the geographical equator but can move to the northward or southward with seasonal migration of the sun. Like sun's zenith position is followed by him, which means it moves northward during the northern hemisphere in summer's time and southward during the northern hemisphere in the winter's time. This movement is due to the tilt of Earth axis that is related to its orbit around the sun, causing the sun's direct rays to shift between the Tropic of Cancer and the Tropic of Capricorn throughout the year. Convergence of trade winds. The trade winds that blow from the subtropical high pressure belts toward the equator in northern hemisphere and the northeast trade winds in the southern hemisphere and the southeast trade winds that were blowing near the equator, all these got converged. As these trade winds approached the equator, they got heated by the warm tropical waters that causing the air to rise. Rising motion creates a zone of low pressure along the equator that is known as ITCZ. If we talk about the weather and climatic impact of this, ITCZ is abundant with the cloudiness and the heavy rainfall, making it a region of frequent precipitation. Plays a crucial role in the global distribution of rainfall, influencing the monsoon system in the regions around the world. Seasonal movements of the ITCZ affects the timing intensity of monsoon rains in tropical and subtropical regions. Like in South Asia, the northward movement of the ITCZ during summer brings a southwest monsoon, which is responsible for the majority of rainfall in the Indian subcontinent. Thereafter, the impact on the weather pattern. Convergence of trade winds and the associated rising air in the ITCZ create a dynamic weather environment. Okay? Thunderstorms and cyclonic activity can occur within or near the ITCZ due to the instability caused by the rising warm air. Changes in the position and the strength of the ITCZ could lead to the fluctuations in regional weather patterns, affecting the agriculture, water resources, and climate variability in tropical and subtropical regions. El Nino is a climate phenomenon that is characterized by the periodic warming of sea surface and the temperatures in the central and the eastern equatorial Pacific Ocean. This warming event has significantly impact on various things. Like if we talk about the name and origin, so basically El Nino is a Spanish name that is used for the child or the Christ child. It often peaks around the Christmas time, that's why it is named as this. Name was given by the Peruvian fisherman who noticed that the warm current appeared around the Christmas season, replacing the cold waters they were accumulated. If we talk about the oceanic changes, first is warm water accumulation. El Nino triggered when the usual pattern of ocean currents and the winds got disrupted. Normally, the trade winds blows from east to west across the Pacific Ocean, pushing the warm surface waters towards the western Pacific, creating a thermocline, a steep temperature gradient, with warm water piled up in the western Pacific and colder water appealing along the coast of South America. Weakening of the trade winds. During the El Nino events, these trade winds weaken or even reverse. This reduction strengthened the warm water to move eastwards and increasing the sea surface temperatures along the coast of Peru and Ecuador. Atmospheric changes. Displacement of the Volcker circulation. The Volcker circulation, a pattern of air movement in the tropical Pacific disrupted during the El Nino. Normally, air rises in the western Pacific and descends in the eastern Pacific. During El Nino, the circulation weakens, leading to the change in weather patterns. Increased convection. The warmer ocean surface temperature enhanced the convection, increasing the cloud formation and the rainfall over the central and the eastern Pacific. This shift alters the typical weather patterns at the global level. After this, if we talk about the impacts of El Nino, first is on the global weather patterns, changes in rainfall. El Nino could lead to an increased rainfall in subregions such as the southwestern United States, while causing the droughts in the others like Australia and Indonesia. The shift in the rainfall pattern can lead to the several flooding and the droughts also. Like the temperature anomalies, warming of ocean waters could lead to the higher than temperature in average size in the some areas, contributing to the heat waves and altering the weather patterns worldwide. Impact on marine life, destruction of fisheries. The warming of surface water reduces the upwelling of cold, nutrient-rich waters along the coast of South America, leading to the decline in fish population and affecting the local fisheries and the marine ecosystem that was existing. Thereafter, impact in the social impacts, agriculture disaster. Changing in the rainfall and the temperature could significantly affect the agriculture, leading to the crop failures, reducing the yields and increase the cost for farmers. Economic cost. Impact on whether the agriculture and the fisheries could lead to the substantial economic losses and increasing the spending on disaster relief and the recovery effects. If we talk about the phases of El Nino, first is El Nino event. This is characterized by warming of sea surface temperatures and the disruption of normal atmospheric conditions. La Nina, the opposite phase where the sea surface temperature in the central and the eastern Pacific cooler than the average. La Nina typically straightens the trade winds and enhances the upwelling of cold water along the coast of South America. Neutral condition. When neither El Nino nor La Nina conditions are present, the ocean and atmospheric conditions are in a balanced state and there is nothing to do with. Prediction in monitoring, MONT system. Various scientific organizations and the meteorological agencies like the National Oceanic and Atmospheric Administration, NOAA, they use the satellite, BEOS and the oceanic data to monitor the sea surface temperature and predict the El Nino events. Impact on forecasting. Advanced climate models and historical data helps to predict the onset, intensity and duration of the El Nino events, allowing for the better preparedness and the mitigating strategies at worldwide level. Okay. So students, basically in this lecture, we have finished the monsoon and the climate. In the next lecture, we will start with another important topic. Till then, just revise the facts and figures that all we have discussed in this lecture. Be ready for the next lecture. With this note, let's end this lecture and thank you.